Another way of finding the determinant of a matrix is by the cofactor expansion method. So first, let A equal to Aij be an n by n matrix. The submatrix Mij is the n minus 1 by n minus 1 matrix obtained by deleting the ith row jth column of A. The determinant Mij is the minor of Aij. The cofactor Aij of the entry or the element Aij is defined by Aij equal to -1 raised to I plus j times the minor Mij. Okay, so first we have to obtain the submatrix Mij, which is n minus 1 by n minus 1 in size. This can be obtained from A by deleting the ith row jth column. So if it is M sub 2, 3, you delete the second row, third column of A. If you take its determinant, then it is called the minor of Aij. If you multiply the minor of Aij, or the determinant Mij, by the factor -1 raised to I plus j, that is called the cofactor of the element Aij. Alright? So we shall now define the determinant of A. The determinant of A, or that of A, by expansion about the ith row is AI1 plus AI2 up to AIN. So in other words, the determinant of A can be obtained if you are expanding about the ith row by the sum of the following products. The element AI1 multiplied to the cofactor AI1. The element AI2 multiplied to the cofactor AI2, and so on and so forth, and AIN times the cofactor AIN. So the entries AI1, AI2, AIN are actually the elements along the ith row where we are expanding. So we take on the elements of the ith row if we are expanding on the ith row. If we are expanding about the first row, we'll be using the elements along the first row. And these elements are multiplied correspondingly to their respective cofactors. You may also get the determinant by expansion about a column. So, By expansion, the determinant of A by expansion about the jth column is given by A1j, A1j plus A2j, A2j up to ANJ, ANJ. So if we are to expand about the jth column, all the elements along that column, A1j, A2j up to ANJ, are multiplied correspondingly to their respective cofactors. Alright? So whether we expand about a row or about a column, we will be getting the same determinant for the matrix A. Remember, the cofactor Aij is obtained by multiplying the minor Mij to negative 1 raised to I plus j. So if you want to find the cofactor A23, that will be negative 1 raised to 2 plus 3, 2 being the row position and 3 the column position. Okay? And then multiplying it by the minor M23. M23 is the submatrix obtained by deleting the second row third column and then getting its determinant. Okay? So let us have an example. For this matrix A, we determine the determinant of A. Alright? But before we get the determinant, let us do some exercises here. Let us find M32. M32 is a submatrix obtained by deleting row 3 and column 2. So your M32 will be equal to, we delete the third row and the second column. Alright? So deleting this third row and this second column will come up with a 3 by 3 matrix. Alright? And what are the elements? That will be, okay, that will be 4, negative 2, 0, 2, 0, 1, 0, negative 2, negative 2. So delete the third row, second column. 4, negative 2, 0, 2, 0, 1, 0, negative 2, and negative 2. Okay? Another one. Let us get M4, 4. Delete the fourth row and fourth column. M sub 4, 4 is again a 3 by 3 matrix. Delete the fourth row, fourth column. We have the elements 4, 3, negative 2, 2, 1, 0, 3, 2, and negative 1. Delete the fourth row and fourth column. 4, 3, negative 2, 2, 1, 0, 3, 2, negative 1. So, if you want to find the minor of A32, which is the determinant of M32, since this is a 3 by 3 matrix, you can apply the basket weaving method. So 4 times 0 times negative 2 is 0, 2 times 1 times 0 is 0, 0 times 2 times negative 2 is 0. Okay? So 0, 0, and 0. Then minus 0 times 0 times 0 is 0, minus negative 2 times 2 times negative 2. That will be positive 8. No? So negative 8. And then minus 4 times 1 times negative 2 is negative 8. So minus negative 8, that is positive 8, and that will be equal to 0. Okay? So once again, let us check that. 0, 2, negative 2, 1, 0 is 0, 0, 2, and negative 2 is 0. Minus 0, 0, 0, minus negative 8, so that is positive 8. So negative of positive 8 is negative 8. And then minus the product of 4, negative 2, and 1. So minus negative 8, that will be positive 8. How about the minor M sub 4, 4, or the minor of A44? So again, we apply basket weaving method. 4 times 1 times negative 1 is negative 4. 3 times 0 times 3 is 0. Negative 2 times 2 times 2 is negative 8. Minus negative 2 times 1 times 2 is negative 6. So it becomes positive 6. Minus 3 times 2 times negative 1 is negative 6, so it becomes positive 6. Minus 4 times 0 times 2 is 0. So what do we have here? Negative 4 and negative 8 is negative 12. 6 and 6 is also 12, so that is also 0. Okay? How about A of 1, 2? That will be equal to negative 1 raised to 1 plus 2 times the determinant of, we delete the first row, second column. So first row, second column, that gives us 2, 0, 1, 3, negative 1, 1, and 0, negative 2, negative 2. Okay? We delete the first row and second column. So 2, 0, 1, 3, negative 1, 1, 0, negative 2, negative 2. Okay, so what do we have? Negative 1 raised to 1 plus 2. That is negative 1 raised to 3 is negative. Times, let us get the determinant. 2 times negative 1 times negative 2 is positive 4. 0 times 1 is 0. 1 times 3 times negative 2 is negative 6. Minus 0 minus negative 4 is positive 4. And then minus 0. So what do we have here? 4 minus 6 plus 4 is positive 2, preceded by a negative sign. That will be negative 2. Okay? So let us now determine the determinant of A. So let us expand about the first row. So expansion about the first row. Okay? So the determinant of A is equal to the elements of the first row multiplied correspondingly to their respective cofactors. So A11, A11 plus A12, A12 plus A13, A13, A13 plus A14, A14. Okay? So what is the element A11? The element A11 is 4. So 4 is multiplied to the cofactor. What is the cofactor? Negative 1 raised to 1 plus 1 times the determinant of. We delete the first row and first column. This one. So deleting the first row and the first column, we will be getting the elements 1, 0, 1, 2, negative 1, 1, 3, negative 2, negative 2. Then we go to the next element, A12. A12 is 3. So 3 times the cofactor, A12. That will be negative 1 raised to 1 plus 2. Determinant of. Delete the first row and the second column. So what does it give us? 2, 0, 1. 3, negative 1, 1. And 0, negative 2, 2. 0, negative 2, negative 2. Then, we go to the element A13. First row, third column, so that will be negative 2. So, plus negative 2. Multiply to the cofactor A13. We just multiply this by negative 1 raised to 1 plus 3. And then delete the first row, third column. And what do we get? 2, 1, 1. 3, 2, 1, 0, 3, negative 2. Then finally, we go to the element A14, which is 0. Just to illustrate, let us write here 0 times A14. And A14 is negative 1 raised to 1 plus 4, determinant of. We delete the first row, fourth column. That will be 2, 1, 0, 3, 2, negative 1, 0, 3, negative 2. Okay, at this point, since an entry here, A14 is equal to 0, actually, there's no need of multiplying or writing the cofactor. Anyway, the product will be 0. So, you should realize that if you are given a large matrix and you are using the cofactor expansion method, it is better that you expand about a row where there are plenty of 0 entries. No? The more 0 entries there are along the row where you are expanding, the better, and the shorter the solution is. Okay? So if you are to use the cofactor expansion method, identify that row or column where there are many zeros. In that way, it will shorten the solution. Okay, so let us continue. So the determinant of A is equal to 4 times negative 1 raised to the power of 2, that will be positive 4. Multiplied to the determinant. So let us apply the basket weaving method. That will be positive 2, 0, minus 4, minus minus, so that will be plus 3, 0, minus minus 2 or plus 2. Okay? Then we go to the next. 3 times negative 1 raised to 3. Negative 1 raised to 3 is negative. So times 3, that will be negative 3. Times the determinant. 2 times negative 1 times negative 2 is positive 4, 0, and minus 6. Then the diagonal to the left, 0, 0, minus minus, so plus 4. Okay? And then negative 2 times negative 1 raised to 1 plus 3. Negative 1 raised to 4 is positive. And then times negative 2. So minus 2. Multiplied by the determinant. This will be negative 8, 0, plus 9, minus 0, minus minus 6, so positive 6, and then minus 6. So what do we have here? 4, 3, 2 minus 4 is negative 2, negative 2, positive 3 is positive 1, plus 2 is 3. And then minus 3, wait, this will be, let me check that. What do we have here? Negative 3, this will be negative 6, positive 2. Okay? Minus 2 times, or minus 2 times, negative 8 plus 9 is positive 1, 6 will cancel. So positive 1. So we have 12 minus 6 minus 2. That gives us the determinant A equal to 4. Okay? So will you get the determinant by expansion about the third column? Okay? Find the determinant of A by expansion about the third column. So we pause for a while and then you work on this. Okay, so you should have arrived at the same answer of 4. So wherever you expand, be it any row or any column, the determinant that you should get should be equal to 4. If by expansion about two different rows or columns, you get two different values, then you have to check your work. Because the determinant must be constant wherever you expand, be it a row or a column. Then let us have another exercise. Find the determinant of the matrix below. So let us call it again as matrix A. 1, 3, 0, 4, 0, negative 2, 6, and 3, negative 2, 0, 3, and 5, negative 1, 1, 0, and negative 2. Okay, so work on this, and then when I come back, we will solve it by expansion about, okay, you decide first where you are going to expand, what row or what column, and then I will solve it later. Okay, so let us now work on the determinant of A, and let me expand about the third column. Why? Because as you can see, there are 2 0 entries along that column. So our computation here will be abbreviated. So the determinant of A equal to, we indicate here, expansion about the third column. Okay, so it should be A13, A13 plus A1, A23, A23, A33, A33 plus A43, A43. But since A13 is 0, the entire product A13, A13 will be 0. Same thing for A43 and A43. Alright? So it's just the elements A23 and A33. Okay, so that will be 6 times -1 raised to row position, row 2, column position 3, so 2 plus 3. Determinant of, we delete the third row and the third column and the second row. No? Second row and third column. So we'll be getting 1, 3, and 4, -2, 0, and 5, -1, 1, and -2. Then we go to the next entry, A23, and A23 is 3 times -1 raised to 3 plus 3, determinant of. We now delete the third row. So 1, 3, 4, 0, -2, 3, and -1, 1, -2. So 6 times -1 raised to 5, that will be -6. Okay? Then, what will be the determinant? 0, -15, and -8. Then 0, -12, and -5. Okay? Then 3 times -1 raised to 6, that will be +3, times 4, -9, 0, -8, -3. So -6 times, how much is this? -40. Then 3 times 17, 20, that will be 16. -16. So -20 and 4 is -16. Okay, so it's -6 times -40 is 240 minus 48, and that gives me 190. Okay.